Hello, today I'll be talking briefly about the How Sweet It Is handout. I'll only be looking at parts 1 and 2, which were the parts that everyone had to do. 3 and 4 were optional, so at this time I'm only going to look at parts 1 and 2. So the first page talks about two different sweeteners. Okay, we have fructose and aspartame. So fructose is in regular soda, aspartame is in diet soda. They're two different sweeteners, so they both taste sweet. However, fructose, our body will break down into carbon dioxide and water and get energy when it does that. So you can think of when we talked about thermodynamics, the breaking down of fructose is exothermic, and our body uses that energy to stay alive. However, aspartame, our body cannot break down. So we can't break it down, we can't get the energy that's stored in the bonds out, and so it has 0 calories or 0 energy for us. So the first one, which do you think has more mass? 1 mole of fructose or 1 mole of aspartame? You can just look at the size of the molecules. Which one looks bigger? The aspartame. Okay, the aspartame's larger, therefore it will have more mass. For number 2, what is the mass of 1 mole of each sweetener? So this is where you're going to need your periodic table. I want you to do a calculation for both fructose and aspartame. So I'll briefly talk about how to do it for fructose. Okay, so 1 mole of fructose weighs some number of grams. So fructose from up top, C6H12O6. So when you go look on your periodic table, okay, you want to do 6 times the number for carbon, because I have 6 carbons, plus 12 times the number for hydrogen, plus 6 times the number for oxygen. So that's how you do the math, and when you do that all out, you should get 180.18 grams. So you want to do the same thing for aspartame. You'll need to be looking on the periodic table. Okay. For the third one, which has more molecules, 40 grams of fructose or 40 grams of aspartame? This is the type of problem. I have the same weight of each, okay, but the fructose is smaller than the aspartame. Okay, the fructose molecules are smaller, therefore it takes more of them to get to the weight of 40 grams. So 40 grams of fructose has more molecules. Same weight, they balance on a scale, okay, but fructose has more molecules because they are smaller. The second page is where you have to start doing some calculations. So how many moles of fructose are in a can of regular soft drink? So a can of regular soft drink has 40 grams of fructose. So we start with the number given in the problem, put it over 1, multiply by a fraction. I need to cancel out grams. And I want to end with moles. The question asks how many moles. Okay? So to fill in those numbers, I go back to the first page. So 1 mole of fructose is 180.18 grams. 1 mole, 180 grams. Those units cancel, and I'm ready for my calculator. So I multiply straight across, not cross multiply, straight across. Okay, and then you should be ready to punch that in. So you want to do something similar for number 2. Okay, instead of 40 grams, you're not using 40 grams, you're using this 0.225 grams, and you're not using 180, but you're using the molar mass that you calculated for aspartame on the front. So the molar mass you calculated for aspartame is what you're using to finish that off. Okay? When you do that and you get to number 3, the answer you have for number 1 should be bigger than the answer you have for number 2. meaning you have more fructose, less aspartame. So a can of regular soft drink with the fructose in it has more molecules of sweetener. Because the regular soda has more sweetener, the diet has fewer molecules of sweetener, but they taste about the same. Question 4 says, which is sweeter, the fructose or the aspartame? Well, you don't need as much aspartame to make the diet soda as sweet. So aspartame would be the sweeter molecule, and then it just asks you to explain that out. Hope this was helpful. Talk to me in class if you still have questions.